All right, I kind of warned you in this chapter that about every section I'm going to tell you this is really important. This is another one. This section will get you a couple points on the ACT as well, out of 60. Okay, because they love using 45, 45, 90, 30, 60, 90 triangles. It's gonna, you guys just need to be able to do these kinds of problems backwards and forwards, and the only way to do that is to practice it. Okay, so a couple of things. In order to figure out, is this what I want to do? Isosceles. Well, just do this. An isosceles right triangle. This actually comes from just taking a square and splitting it in two. We get an isosceles right triangle. Okay? So if I said this leg was 1 and this leg was 1, how can I find the hypotenuse in a right triangle? How do you find the hypotenuse? Pythagorean theorem. Right? 1 squared plus 1 squared is 2. And then I have to take the square root of that, right? Because it's 1 squared plus 1 squared equals c squared. So 2 equals c squared. Then I take the square root. C is equal to the square root of 2. So all isosceles right triangles follow the 45, 45, 90 rule. Meaning this angle is 45. This angle is 45 because this diagonal split this square in half, right? And if one angle here on the corner is 90, split it in half, it becomes 45. So this is a 45, 45, 90 triangle. And it always has the pattern 1, 1, square root of 2. Okay? What this means is if I have a 45, 45, 90, and this is 5, it becomes 5, 5, 5 square roots of 2. Okay? So to get from this leg to the hypotenuse, I multiply the leg by the square root of 2. What if the hypotenuse is 5? How do I get back to a leg? Are you guys just working on, or what are you doing? Okay. I just want to make sure that this is important. Don't start the homework until you kind of get through this lesson. If I know the hypotenuse is 5, how do I get to a leg? How do I get to the leg here? To get here, I multiplied by the square root of 2, right? So to get back, what do you think I need to do? Divide by the square root of 2. So to go from the hypotenuse to the leg, I divide by the square root of 2. And these legs are the same because it's a 45, 45, 90. So this leg is 5 divided by the square root of 2. Okay, one thing that you should have learned in algebra is we don't ever have a radical in the denominator. It's bad grammar, bad math grammar to have a radical in the denominator. So the way we handle something like 5 over the square root of 2 is we multiply top and bottom by the square root of 2. This is called rationalizing the denominator. When I multiply the square root of 2 by itself, what's left? What's the square root of 2 times the square root of 2 equal to? 2. Right? Because it's the square root of 4. And the square root of 4 is just 2. So anytime you multiply a radical by itself, it's just the number under the radical, or the radicand is what that's called. And on top, then, I have 5 square roots of 2. So if my hypotenuse is 5, my two legs are 5 square roots of 2 over 2. And I get there by dividing by the square root of 2. Okay, 45, 45, 90. The two legs are always equal. The hypotenuse is always the leg times the square root of 2. I always just say to myself 1, 1, square root of 2. When I think of a 45, 45, 90, I say the pattern, and then I can fill the triangle in with the pattern. In the book, they used x squared root of 2, which is fine, but I just make it the most simplified 45, 45, 90 I can think of, which is 1, 1, square root of 2. Okay? The 30, 60, 90 is created starting with an equilateral triangle. All sides are equal. And I take an altitude down, which splits this and this equally in half. So let's just say all the legs were 1. What is the leg here on this right triangle? 1/2. Okay, so now using Pythagorean theorem, I can find the altitude. So let's just call it A. A squared plus 1/2 squared equals 1. 1 squared is 1. With me? So I'm solving for A. So I have A squared equals 1 minus 1/4. Because this is 1/4, and then I subtract it from both sides. A equals 4 over 4 minus 1 over 4 is 3/4. Take the square root of both. Well, the square root of 3 is just the square root of 3. Square root of 4 is 2. So this leg is the square root of 3 over 2. Is that right? 1, 2, square root of 3. That's right. So if I multiply everything by 2 to get rid of this fraction and this fraction, my 30, 60, 90 becomes 1, 2, square root of 3. I multiply this by 2, I get 1. Multiply this by 2, I get 2. Multiply this by 2, I get the square root of 3. You don't have to prove it every time you do it. This is what you need to know. In a 30, because this would be 60 degrees here and 30 here, because in an equilateral triangle, all angles are 60. So this bottom angle is 60, and this is 30. So in a 30, 60, 90 triangle, what I always say to myself is 1, 2, square root of 3, because it flows better. 1, 2, square root of 3, 1, 2, square root of 3. Remember, in any triangle, the side opposite the biggest angle is your biggest number. The side opposite the smallest angle is your smallest number. Okay, so when I arrange these numbers in order, they look like this. This is opposite the 30. This is opposite the 60. This is opposite the 90. Okay, so if you remember the pattern, 1, 2, square root of 3, you can then arrange your sides opposite the correct angles and draw your triangle. And the way we use these triangles, let's make this 6. If I know the side opposite the 30 is 6, how can I find the hypotenuse? Well, what do I do to get from here to here? Double it. So to get from here to here, the hypotenuse must be 12. What do I do to get from here to here? I multiply it by the square root of 3. So this is 6 square roots of 3. You can solve any 30, 60, 90 triangle given one leg, the hypotenuse, any of those, and use this as your guide to figure out the other two. Just ask yourself, how do I get from here to here? Or how do I get from here to here? Whatever side you're missing, go back to your original 1, 2, square root of 3 triangle and use that as your pattern to figure out any 30, 60, 90 triangle. Okay? I guarantee you're going to have a question like this on the ACT. Promise. They love 30, 60, 90, 45, 45, 90 triangles. Sometimes their questions might start with a square. and they'll give you the hypotenuse. But if you recognize a square divided by 2 is a 45, 45, 90 triangle, you can solve any square problem. Or they may start with an equilateral triangle and give you an altitude and want you to find the altitude. Well, if you recognize that the 30, 60, 90 triangle comes from the equilateral, you can solve any equilateral problem. Sometimes they'll just actually give you a 30, 60, 90 triangle and ask you to figure out what one of the sides is. Okay, so using the 30, 60, 90 real quick, let's do this. The side opposite the 60 is 2. How can I find the other two sides? Okay. If you're not given the side opposite the 30, that should be the first thing you try and solve for. Because do you notice, to get to the hypotenuse, I multiply the side opposite the 30 by 2. And to get to the side across the 60, I multiply the side opposite the 30 by square root of 3. So if I have that side opposite the 30, I can get to either of the other two sides. So if they don't give it to you in the problem, which I didn't, that should be the first leg you solve for, is the side opposite the 30. Because once I have that in this problem, all I have to do is double it to get the hypotenuse. Do you see that? To get from 1 to 2, it's just double. Okay, so ask yourself, look at your original triangle. What I'm given is this. How did I get from here to here? I multiplied it to get from here to here by the square root of 3. So to get backwards, I've got to divide it by the square root of 3. Okay, so this becomes 2 divided by the square root of 3. Well, there's a radical in the denominator again. Have to rationalize. What's that? Yes, it would be. And let me just show everybody else why. I have to rationalize it by multiplying top and bottom by the same root that's in the bottom. Remember that the square root of 3 times itself is just the number under the radical. So this is actually 2 square roots of 3 over 3. And now, how do I get from the side opposite the 30 to the hypotenuse? I double it. This doubled is 4 square roots of 3 over 3. Okay, so you're using the 45, 45, 90, 1, 1 square root of 2, and the 30, 60, 90, 1, 2 square root of 3. Draw your example triangle always for now. I don't have to draw them anymore because I know them. But always use that as your guide, and just ask yourself, if I'm given this, how do I get back to the side I need? And then perform that operation on whatever numbers you're given, making sure you rationalize your denominator if you need to. Yes?
What was the 44, 45,
1, 1 square root of 2. And they're up here. They use x instead of 1. But it's the same idea. Whatever number you have on this leg, you're going to multiply it by the square root of 2 to get the hypotenuse. Whatever number you have across from the 30, you're going to double it to get to the hypotenuse. You're going to multiply it by the square root of 3 to get the other leg. I just remember I have this mantra. And those of you who ever take trig, you're going to become really good at these. But for now, you want to become really good even for geometry, for the sake of your ACT. Because it'll save you points, and you're going to get them just like this and be able to go to the harder ones and have more time, which is the key to getting through math and the ACT. It's not really what you know, it's getting to answer all 60. Because Kate, who's in Calc this year, hasn't finished math ever. Because she thinks so slowly, I can't get her to, so I'm trying to give you ways to answer some questions quickly, and this is a good strategy. If you know your 45, 45, 90, your 30, 60, 90, you won't sit there using Pythagorean theorem to try and find a missing side. You can see it within 5 seconds and move on to the next one that might be more difficult. Okay, because using your time wisely on the ACT is how you get through it and have a good score. Because by the time you're through with Algebra 1 and Geometry, some Algebra 2, you know everything you need except maybe 2 questions on the ACT. So you could get a 58 out of 60 if you could just get through the questions quickly. But they get progressively harder. The first 10 are the easiest, and they get progressively harder. So some of this will probably fall somewhere mid-ACT. Okay. The only way you're going to get good at it, where you can just do it at the drop of a hat, is practice. So we're going to do 8-3 today, and then what's 8-4? Can't remember. Okay, so 8-3 today, covering both 45, 45, 90, 30, 60, 90. Tomorrow, we're going to just do a worksheet to practice these some more. Okay? Today, you've got big ideas and CK12. Tomorrow, you're going to have just more practice, because the more you do them, the faster you're going to get at them. Let's go through the textbook check real quick. Is it thinking? Okay, all isosceles right triangles are 45, 45, 90 triangles. True. If there's a radical in the denominator, you should rationalize the denominator. The ratio you use for a 45, 45, 90 triangle is x root 2, or 1, 1, square root of 2. True. The ratio you use for a 30, 60, 90 is 1 times the square root of 3, 2. So that is the last one here, x root 3, 2x. And then finally, in the James Sousa video discussing solving right triangles, he creates a 30, 60, 90 starting with a equilateral triangle. And that is it.